Hey, what's going on, guys? Today is solution day and one more week, and quite interesting. A lot of you really like this question of fireworks, and I wasn't sure. It's conceptually a very simple question, but it seems like it generated some interest. I love questions like these where you have, some sort of practical application of trigonometry. It is always good to see. So even though this is not rocket science, still a great question. So the question, some of you said that it cannot be solved because there is no perspective of the viewer. We don't know where the viewer is. Partly it's correct, but the question does say that sky as shown. So it's looking for the perspective as you see it in there, or even if the viewer is in the city, let's say the fireworks is for the city, the viewer is in the city, they're far away, so the angles of the launch tubes will be preserved, and quite frankly, this is how a lot of the fireworks are done. So let's get down to it. The basics of this is quite simple. You have to make the triangle, plot the triangle where it's going to be. It's going to be something like this. Okay? So when you get that triangle, and we need to find what this angle is, theta. Okay? And these sides, you're given the ratio. Grade A fireworks has a calibration of 300, and grade B has a calibration of 800. What that means, if the explosion radius of grade B firework is half, so the small firework right here is about half. So let's just say this radius is x, that this radius will be 2x. Okay, so the whole side becomes 3x. And now it's telling the calibration of the grade A firework is 300%, so that is the ratio of the radius to the launch distance, which is this. So it's 3 times, so this will be 6x. This one is 800, so this will be 8x. So it trivializes the problem that your triangle is now, it's not a right angle triangle, of course. It's a obtuse triangle. But once you have the ratio of the sides, which is 3, 6, and 8, 3, 6, 8. The angle is pretty trivial after that. It would be 8 squared minus plus 6 squared minus 3 squared divided by 2 times 8 times 6. And that would be about 91 divided by 96. So that will be a cosine. So if you take the cos inverse, now it does say calculator, okay, so you could plug this in, get your cosine, the number would be something like 18.57 degrees, which is the closest answer to 20. So about 20 degrees is the angle required to launch this firework. So that was fairly simple using the cosine rule. Well, the main part of the question was, can you get to the ratio of the sides? So pretty good. The next one I had some activity about was the ratio and proportion question. Again, it was a fairly interesting question. It gives you the population. A third of Bomers are Hagees, 200% more of Hagees are 2/3 of Banlans. If Bomers, Hagees, and Banlans make up 50% of the population of Parlovia, approximately what percentage of Parlovian population are Banlans? So let's just start making a ratio. Let's just say Bomers are B. A third of Bomers are Hagees. Okay. 200% more of Hagees are 2/3 of Banlans. Now here's where a lot of you got the question wrong, the messages that I got. 200% is not 2 times H. It's not 200%. When you say 200% more, it's like saying 20% more is multiplier 1.2, so it's 1 plus 200 divided by 100. So 200% more is actually 3 times the value. So 3 times of Hagees are 2/3 of Banlans. So let's just call them Bn. So put the value in here. So B equals 2/3 Bn, which means Bn is equal to 3/2B. So it wants to know what percentage of the population are Banlans. So we know that Banlans expressed in the terms of Bomers, B is 3 divided by 2B. And then let's just take, what's the Parlovian population? It would be 50% of the population. All 3 of them make up half the population. So the total population is 2 times the sum of the 3 Bohmers, Heges, and balance. So let's just say B plus B by 3, those are your Heges, and then you've got your balance, which is 3 over 2B. If you ratio calculate that, you will come up with 26.47. So choice B. So interesting question. It tests you on a lot of things simultaneously, but the catch of this question was understanding 200% more what that means. When somebody says 20% more, when somebody says 20% more is 1.2. When you say 200% more is basically 1 plus 200 divided by 100, which will come up to 3. So 200% more is not 2 times h. It would be like saying 20% more is 0.2h. So once you get past that, it's a common mistake, and SAT and a lot of other tests, especially banking tests, will test you something like 200% more return on investment. So they don't mean 200% of the initial, they actually mean 200% more the delta. So pretty good. There'll be a lot more questions this coming next week. I'll be going a little bit into calculus. Some of you have asked about integral calculus, even though that is not really an area that is tested for the SAT, but it's quite popular in the IITs and the ACTs and Olympiads, quite a few other decathlons and stuff. So I'll go over a little bit into calculus, and don't be scared. It's not going to be that hard. But try some of the other questions, geometry questions, and let me know what you think of those. And if you want any particular question answered, just send me a message. Well, that's it for today. Happy Easter, everybody. Bye-bye.